Hello everyone, welcome to this seminar with system verification, and Alisa is going to guide us and provide some examples today about how we can benefit from AI in our software, doing software testing. My name is Magnus, and I've been working with system verification for 12 years now, and I've been working with them for at least 15 years, something like that. And that is kind of the whole time system verification had existed. We are now celebrating our 20th anniversary. So that is kind of a great thing to celebrate. Most of my time I spend working with different customers, helping them improve the processes when they're trying to work agile, or I'm helping them with the business requirements. But as long as you can improve the quality in some way, I do try to help them. I'm also responsible for other things that we're doing. For example, we do have PhD students, so I'm part of helping them out, since I've also already had my own PhD now quite many years ago. And that is kind of important to us to be on the leading edge when we're talking about being the quality assurance company in more or less Europe now when talking. So as I said, system verification has been around for 20 years, and we are working with lots of different areas. We have, for example, we have expertise in different areas like continuous integration, continuous delivery, but also very much focus on test automation, performance test, and of course also a normal function and integration tests. As I mentioned, as I do myself, we're working a lot with assessments. Nowadays, we do a lot of software due diligence things, performance checks, and also new to us is doing healthy checks for the software that the customer's software. Also, as part of this, we sometimes do vulnerability checks or security testing checks. Part of this new things is that we're doing quality monitoring to help you, guide you through the quality or the health of your software in different ways, so you actually can pinpoint where it would be most beneficial to take care of your technical depth. So yes, we are in very many areas where we do have the quality assurance activities. As stated, the leading company in Europe, maybe a bold statement, but we do expand. So today we have a couple of offices here in Sweden where we have the headquarters, but now also we have a very large office down in Sarajevo in Bosnia-Herzegovina. And recently we established in Germany, and we are also established in Poland. So we are kind of in a number of places now around Europe. So AI, it's talking very much about this, as you can normally hear. You read in newspapers or you read different blog posts, and AI is the top thing most of the time. But the question is, how can we benefit from this? Normally you think at its high level, it's very complicated, but today Alisa is going to guide us through and how we actually can benefit from AI in our daily work. And in this presentation, there will be an introduction, and then there will be a demonstration as well, where she will guide us through how it can be used. And at the end of this seminar, there will be a Q&A session, and you're of course welcome to raise your questions. Please save them until this Q&A sessions, and you can of course always write in the chat if there's something specific you would like to know more about, and I will bring that up after the presentation and when we go into the Q&A session. So with that said, welcome once again, and I hand it over to you, Alisa.
Thank you very much, Magnus. Hello, everyone. My name is Alisa, and I work as a test automation engineer at System Verification in Sarajevo office. I've been employed in this company for almost 3 years. Before that, I had an opportunity to work for some other local companies here in Sarajevo as well. So I have around 10 years of experience overall. My current position and job are mainly involved into test automation, but as Magnus said, we at System Verification, we always try to investigate and find what are the best ways to improve quality of the software and to propose the best solution to our clients, but also to learn a lot. So that is why I have decided for this topic, for this webinar. I believe it's very interesting. And thank you very much for joining. I'm sure that you are going to learn something, that you will find this very useful, and maybe you will be able to use something, or at least to get some ideas on how to improve your daily work. And if that is not the case, I hope that after this webinar, you will have some ideas about learning process when it comes to artificial intelligence and software testing, and how that is connected now and what is the future. So before going into further details about how software testing can benefit from artificial intelligence, we should first ask ourselves and answer the question, what artificial intelligence is. When I was Googling the answers about how people perceive this terminology and what they believe artificial intelligence is, most of the people, of course, not including people who are working in a software development industry, have a very interesting and funny thoughts about what artificial intelligence is. And this image is somewhat showing their opinion. They believe that artificial intelligence is related to robots, huge robots, who are going to be on Earth and fighting against the people and not doing nothing good for people or humanity. Also, some of them believe that artificial intelligence is just another term for aliens and stuff like that. So for me, it was very interesting to read about it. But the truth is that artificial intelligence is something quite different. First of all, to say that this is a very, very complex area, and we would need lots of webinars and also people knowing this area to give all of the answers that we will have in our mind even after this presentation. But in a nutshell, we can say that artificial intelligence is a computer system that is able to perform tasks that require human intelligence. The base of artificial intelligence systems and how they work is by using large amounts of labeled training data, analyzing the data for the correlations and patterns, and using these patterns to predict the values. So that is, let's say, some simple definition of what artificial intelligence is. Predicting some values that, and I mean, not only that, but that is the part that we will show and use in this presentation. It is also important to mention that artificial intelligence is not just a future and something that will happen. Artificial intelligence is present, it's already in our life, and probably most of us, if we are looking in the examples from this slide, had the chance to experience and to use artificial intelligence at least a couple of times. So, for example, when it comes to social media feeds, all of us, when we get our phones, we open social media networks. We scroll for something, search for some content, scroll down, open that content and similar. And when we get back to our social media afterwards, we will receive feeds that are based on what we were searching before, people's suggestion that we may know, that we may be interested to follow, and similar. It is also very similar to online ads network. If we are browsing something or buying on internet, it's probably very often the case afterwards will be that you cannot get rid of ads, that it will be shown for you just because you were Googling and searching for something. The reason for this is that behind this, there is a huge system which is following our behavior and which is learning from our behavior. And based on learning, it predicts what maybe could be interesting for us, and it gives us suggestions about that. So this is something that I believe all of us had a chance to experience. There are, of course, a lot of examples of artificial intelligence today, and I've listed just a couple of them. For example, smart cars and drones. This is also something that is already present, and I can only imagine how the future will go with artificial intelligence development so far. Also, banking and finance and healthcare systems. While I was investigating the benefit of AI in, overall, not just software testing, but the real life and daily life, I found that healthcare is something which is maybe the most interesting and more useful from my point of view. So there are out there some big healthcare companies that are investing their money and their resources to build artificial intelligence system that will be able to predict a disease based on the patient's profile. So that is very good because people will be aware of what can happen to them and how to act to avoid that. So we can see that artificial intelligence, at least for now, it's nothing about robots who want to destroy humanity or similar. It's a huge science that people are using to make everyday lives easier and more quality. And of course, software testing is going to be affected by artificial intelligence a lot. This is maybe still not the case for most of the companies on the market, but definitely we are going to see the new age of software testing with artificial intelligence and machine learning. The key value proposition of artificial intelligence is the fact that it can reduce the direct involvement of the human in multiple routine tasks. And I also believe that most of us in our daily work were in the situations where we were like, okay, it would be very good that I don't need to work this every day, to have some system who is smart enough to know what to do because I'm doing this anyway all the time. Why can I have some robot to do this for me? And of course, the changes that AI will bring when it comes to software testing is the first change is going to be possible to do visual automated validation UI testing. So far, with some automation frameworks that are on the market that we are using, are able to do some level of UI validation testing. But that turned out to be not very safe. The bugs were not really bugs, and also it was very time consuming. With the artificial intelligence, this will be very easy and not time consuming to do. It will also affect the way that we are going to test APIs. And also there will be new concepts and frameworks that will enable to run more automated tests that matter for current deployments, changes, and stuff like that. And most of the QA engineers are struggling with this very often to decide what set of tests to execute, what is really important and stuff like that, but still to not be that part in the pipeline who will take the most of the time. Artificial intelligence in software testing will also bring a lot of challenges in test automation. There are already tools on the market that are using artificial intelligence systems and machine learning models to improve and provide new way of software testing. I listed a couple of tools here. This webinar is not about presenting any of these tools. It's more about giving the input what is on the market so far. I had a chance to work with the Apple tools, and it's a very, very powerful and good tool. The bad thing is that most of these tools are very expensive. So the companies will probably, at least for now, think twice before buying these tools, because artificial intelligence is still something that people are not understanding and using so far. So they maybe don't believe it's needed. But the good thing is that all of these tools have a free trial. So I suggest you that you take a look when you find time to see what are the real changes that are happening already. Okay, so this was the short presentation about AI in general, how we can, where we can find artificial intelligence and how it affects software testing. Now the purpose of this webinar is, besides that, to have a short demo where we are going to try to solve one problem with the help of the artificial intelligence. And the problem is, every time code is deployed to different environment, it's hard to decide what is the best set of tests to be executed. I believe we all had this opportunity to work on the deployments where we really are struggling to decide what's the best set of tests to be executed. Our solution is build and train artificial intelligence using machine learning that will help you to select right tests depending on the changes, but also on the environment where the changes are deployed. And the set of tools that are going to be used in this demo are ML.NET. It's a tool to build custom ML models. As far as I know, this is new tool supported from .NET, obviously, and it's a part of Visual Studio 2022. I'm not sure if the previous version have this. We will also use MS SQL database where we are going to store our data and data that we will use for our machine learning model. And we will create short, I mean, not create, but show the short automation project. The point of this demo is not to show automation frameworks to work on what is the best way to write the tests. It's more how we can solve this problem. So I will now just go through scenario. Also, it's important to say, if you want to apply artificial intelligence to make your work better, there are some requirements there. It's first of all, you need to have clearly defined requirements and clearly defined goal, what you are trying to achieve, and is it possible to achieve that with artificial intelligence, and what are your limitations in that case. Also, maybe the most important part is to have valid data and to have a lot of data, because everything in artificial intelligence and machine learning is based on learning on the data, on the history of behavior, history of some changes and something like that. So we will have a couple of assumptions for this scenario just to make it realistic. So let's imagine that we have one huge system displayed like on this image here. It's not one web application, it's not one API, it's a huge system of multiple web applications that are connected. We have multiple databases, multiple APIs, also services connecting between each other and stuff like that. If we have such a big system, we obviously have lots of developers working on this, and they are committing their code to the code base daily, couple of times. And if we have a big system, we need to have several environments. It's not enough to have, let's say, just 2 or 3 environments, which are in that case easily controlled. But in the case of huge systems where each component is somehow connected, having multiple environments is a must. So we will assume here that we have 6 environments, and we have some stage environments. We can consider that as working environments where we have multiple deployments daily. And we have some upper environments where we also have deployments, but with some, let's say, different criteria of the deployment that changes. So in this flow, at the end of the line, we have a QA engineers, always smaller number comparing to developers. And they need to follow each deployment to each environment and to decide what set of automation tests to execute. We know that as a QA engineers, we are always trying to execute as much tests as possible, and we are only confident if the whole regression suite is executed. But in this case, that is not an option because it's not possible. If you have a big system, regression test suite will take a lot of time. And imagine if you have only deployments to stage alpha environment a couple of times a day, and you need to have quick feedback on how the changes are working on the environment. Executing regression test list will make this flow impossible. So as a QA engineers, you need to track what was really changed. What type of application? Was it changed some, let's say, common component that is used by multiple services in the system and stuff like that. And based on that, you will then select the set of tests and execute, also depending on environment where are you running the changes. This, of course, doesn't mean that we should avoid having regression test list. That should be always the part of the testing process, but that is happening. That is something that is happening out of working hours, out of deployments, daily or early mornings and stuff like that. So this is the flow, and it's complicated for QA engineers to decide what and when to execute. So here is the solution for this problem. So the flow is, as I mentioned, let's say we have new changes deployed to the environment. The next step, we will get the deployment details. After getting deployment details, for example, environment, code, code component, application, and stuff like that, we will contact our machine learning model and ask what is the best set of tests to execute for this deployment. And then machine learning model will return, okay, this is set of test categories or one test category that is the best to be executed for this deployment. And then we will execute that set of tests based on what was returned from the machine learning model. And we will show this flow here. But before going into that practical part, I will just say that what we have for the machine learning model on the right side are a couple of boxes. These are actually the steps that we need to perform in order to create one machine learning model. So the first thing is to prepare the data, and this is what I mentioned at the beginning. And even if it seems very easy, it turned out to be almost the most difficult part, to select the right data, but not just the right data, to also select what is the data that will really affect your model, that is really important and should be taken into consideration. After that, we will select machine learning model. When it comes to selecting machine learning model, we need to learn and to investigate, because there are lots of machine learning model out there. So what is the best for us to apply? Here in this particular demo, we will use existing machine learning model. So we will just pull that model with the data. But for example, people who are working on building the real models, they will probably need some work besides using some existing concepts. After that, we will train the data. Training is, as the word says, the word says itself. We have a data, we have a model. Now we will train the data so our model can learn what is expected behavior for what we want to predict. After that, we are evaluating results and we are seeing what are the properties of our model and stuff like that. And after that, we will consume the model. In our case, our model, consuming our model will be to have a list of tests or categories that we should execute for a particular deployment. Okay, I will now share a database that I've created for this purpose. Because I don't have particular application and scenario that I imagine having here. It's, let's say, some overall scenario that we would like to, that we have in practice, and we are now trying to work on that. So what I have here is deployment details table. Deployment details table has a couple of columns, including environment, application that was deployed, code component, what set of tests was selected by our QA engineers in that scenario part at the end when they were selecting that manually. And there is deployment ID, which is in our case not important at all. So this is, let's say, some dummy data that I created, and I populated this table, and we will now use this data in our model. This table has around 20,000 rows. For a demo purpose, this is fine, but when it comes to building models on a real data, this is not enough, and we should have many more data than this. I will now move to Visual Studio 2022, and I will now show you how well, I mentioned we have a small automation project here. We have, let's say, a list of tests depending on different categories. And basically, this is just a dummy test. We are not testing anything here. That is not the purpose. So let's now see how to create and evaluate machine learning model. So on your project, you will click Add, you will select New, and here you can see machine learning model. It will be, let's say, like this. And when you create the model, you will receive this model config file. So we will now just follow the steps. The first scenario, the first step is to select scenario. As I mentioned, we have some automated machine learning models here that we can use. The bad thing of this tool is that a number of models is very limited, only 5. But as I mentioned, for this purpose, this is fine. And also, in order to select right model, you would need to investigate what are the existing machine learning models, what they are predicting, and what values they are using. For our case, we are going to use data classification to predict something that it will be for us tests. So here we will select this training environment and click on the next step. The next step is to add data source. You have, as you can see here, a possibility to add different file types or to read it directly from the SQL. Since I did the setup for the database, we will connect my localhost database webinar. Let's test connection. Okay, now that we have that, the next step is to select the table from the database for which we want to do the model. and it will be deployment details table. And data, all data will be immediately loaded here, also, of course, previewing just a couple of them. Next thing to select is a value, but column to predict. In our case, this is a test column because we want to predict test. And if you click on the advanced options here, you can see that some of the columns are labeled as a features with their purpose, while some other are labeled as a label. So label is something that we want to predict, which is test, and that is fine. And features are values, but not values, but columns that are affecting the tests that we want to predict. So already in the scenario, we mentioned that environment will affect because we don't have same criteria to deploy on some lower environment comparing to, for example, production. Application that it's been deployed also, for example, if we deploy a back office application, we are not sure why would we execute tests for payment. And code component also, it's the part of the code which is changed. Deployment ID, it's just the ID of the deployment in the column. And we suppose that all of this should be the part of the deployment script. So when the deployment is done, some values are inserted into database. So for our prediction, deployment ID, it's not important. And we are going to ignore that value. And we will save that. And we see here that that is updated. And we will now go to the next step. Next step is to train the data. And ML model will give you some based on the data that you have. Is it a small database, small file, number of rows, and other things? It will give you some suggestion how much time do you need to train your model in order to get real results. So for this model and the data table around 2700 and also 1000, and also using free features that are important for the prediction, it will say that around 10 minutes is suggested time. Of course, we won't use this on demo. We will only say, for example, 60. The results probably, and we will get this warning that this is not enough time to do the training. We will say, okay, we are okay with that because I already trained this model. So this is just for the demo purpose. And then the training starts. We have some training results here. When it comes to training and when it comes to what data is used in training. For this ML model, which is automatically selected here, the value is that 30% of the data should be used for training, but this also can be changed. For example, if you are building your own data model, sometimes you will maybe need to use different approach. There is no some rule. It all depends on what is the data and what is the scenario that you are trying to predict. But if you don't have a lot of data, you shouldn't, you can go with a lower percentage, around 10 to 20% of data for training. And if you have a lot of data, then you should use also a bigger percentage for training. Now the training results are here. We can see lots of some information displayed here. This value here actually describes if our model is good or not. So our model here is almost good. 75%. Model should have accuracy 75% to be considered as a good model. So it's a baseline. If this happens in a real life, you will probably need to either to work a little bit more with your data, or to try to increase the training, or to try to increase what is the amount of data that you are using for training. For this purpose, this is just fine. And now the next step would be to evaluate this model. So this means let's test this model. Here we have obviously 3 parameters displaying different columns from our table, and they are, as written here, pre-filled by first row of our data. So let's say if we have things like this, and if we try to predict for stage alpha for this application and for this code component, these are going to be results. So we will say you should execute post-creation tests, and this is obviously the percentage of overall tests. And in my opinion, this is not enough. We cannot be confident with this, with executing only post-creation tests, because we see that, for example, some other components might be affected, some other applications might be affected by this code component. So in this case, what we could do is to create helper method, which is going to get all the results and compare them. And if we see that there is no huge difference between first and second prediction, then we should probably select, let's say, at least 3 or 2 of them. Let's say now that we have production environment, and I think that we have payment or back office application. This. Also here, the results are showing a little bit not good indicator for our test selection. This can be the cause for this not good, let's say, or obvious results, that this model was trained only 1 minute and it should be trained more. So let's try to use other model that I already used before, just to see, is it going to work the same? So here you see for other model that also has better accuracy, we can say it's good. Different set of tests is displayed. So if you, again, I will return this, if your results are not what you are expecting, in a couple of scenarios that you are evaluating for your model, you should think either it's data or training or something. So this is the model which was trained 10 minutes, and you can see that results are different. And now we can play around. There are lots of data in the table that I've used for this, but I mean, this is the approach. In this case, we can say, okay, if the deployment was to this environment, and if we deploy this, this set of tests should be executed. And yes, we can then select anything that we want from the database. Now the next step is to consume this, this model. And I'm going to show how I did this test setup. I already mentioned that these tests are based on the test category. For example, user management tests, we have them here. And we don't have real tests. These are just dummy tests. It's important for us to have for different categories, everything. What is important here is a test setup method. And this is going to be executed before every test execution. So what we are doing here is that we are first getting latest deployment from the database. So the flow here is, we imagine that we had deployment is done. The deployment script was in charge to insert data into database. We will get latest database deployment details that we need. And we will now call this model input, our model test prediction model. And we are going to read what was actually deployed, what are the latest details, obviously. And then we are going to call the model and say, okay, let's predict what is the set of tests to be executed in this case. So I will just debug, no matter which test case, none of them is, just to see what category will be predicted. Okay, so here, of course, we can see details like environment, no environment, sorry, this. So it was deployment to production. Application was, we don't have the info. This is also something that I did on purpose, because let's say that the deployment script didn't work and it didn't really enter the all correct data into database. And let's see if we have code component. Code component would be client service. Okay, so these are deployment details of the latest deployment. We called here the model. We use this data, and now we will go and see that category that we should execute is user management test. So that is basically it when it comes to this automation project setup. I was thinking to maybe save this test category, sorry. I was thinking maybe to save this test category to some field and then to simulate execution, but there is no need for that, because all of this should happen on the environment and should be the part of the pipeline. So this part should be the setup part on the, let's say, our pipeline for test execution, where we would have additional step to get the category, and then we can write this category to database. And the next step, we should read that category and execute tests based on what we have. So that would be the flow on the how it really should look like. And we would avoid here having the QA engineers following deployments and also deciding what and how on which environment should be executed. Also, just to mention that the data that was used here is obviously dummy data, but it was needed in order to create this kind of model. And that's why I mentioned, if you, for example, think of setting up something like this in your environment, you will need not just involvement of the QA team, but you will need involvement of the whole team, because you need also help from the DevOps here to help you and save all of the deployments details that you need, and also to help you set up pipeline the right way so that you can always select and get the latest value. So that is more or less it when it comes to the demo part. And with this approach, we would solve the issue of what QA engineers had on the scenario image that I showed. So what is the final conclusion of everything that we've seen is, the main question to answer is, will testers go the way of the dinosaur if the system will do everything by itself? The answer is no, but we will definitely need to change a little bit our way of working and our way of thinking. Artificial intelligence is very powerful and it will help us to work smarter and not harder. So let's use artificial intelligence to do the work for us that we don't love to do, and it can't do based on our previous behavior. So we can spend our time on learning maybe even new things regarding AI or something else. Also, as I mentioned, the benefits of applying artificial intelligence and machine learning to software testing is very clear, and I believe it has a future. But as I already mentioned, it's a question of allocating the resources needed to build the algorithms and routines, and also involving the whole team to have this setup up and running. So that was it from my side for this demo. I hope that you enjoyed it and that you have learned some new things. And thank you very much again for joining. Now I think that we can switch to the Q&A session.
Yes, thank you very much. Very interesting. Yeah, just to start with then a question. So this is how you have shown what kind of test you can choose. But what would your next step be, your next project to apply this? What kind of ideas do you have in mind now to broaden this?
Currently I am working on one project where I can see potential of implementing maybe something similar because we have a couple of systems connected. There is a lot of deployments, and we are already struggling with following everything, which is natural. The systems are connected, but also have their own functionalities. So the next step would be, it's very important to make managers and to make other team members aware that this needs time and resource allocation, but it is very beneficial. It's very similar to when test automation started. I know a long time ago, many of managers were not believing in that one application can have some clicks by itself. They preferred having a person doing that job. But afterwards, when they saw the real benefit of it, most of the company accepted that way of transition from some traditional manual to automation testing. So for me, the next step would be to try to make my team and managers in the team be more aware of how can all team benefit of this, and then to see what are the options there.
Mm. Yeah, I do recognize this when you're trying to convince people about how you need to do it. And also, as you mentioned, the requirements, what would we like to achieve it? So we don't just throw all the data on into the system and see what we kind of get out of it and how useful it can be. But I'm also thinking if someone would like to learn to know more about this, what do you recommend? Is it some articles, or is it something you find on the YouTube, or how to go ahead to learn more?
Honestly, it was combination of it. If you Google how artificial intelligence is connected to software testing, you will in most of the cases find the new tools on the market that I already mentioned. Mm-hmm. And that was fine, but that is the final product. I was more interested to know how that product was really created, what is using. So at that moment, I needed to leave this software testing terminology behind and just read about artificial intelligence and machine learning. And of course, there are great Udemy courses on this. You will also, if you want to, I mentioned artificial intelligence is very complex, and you need to waste a lot of time to have understanding, but also it will return you back to maybe to the college time, because there is behind everything systems and calculation, and how is that done? There is a lot of mathematics and statistics. So first, my suggestion would be first start with exploring machine learning and artificial intelligence in general, and see how artificial intelligence resolves some other problems not related just to software testing. And in that case, you will recognize at your daily work some, I don't know, maybe areas of improvements where you could really start using this.
I got one question here. Is you could elaborate a little bit more on how to gather realistic training data, because if it's kind of the shit in, shit out effect, so how do we take care of this?
Yeah, that is the hardest part. At least it was for me for this webinar, but also I attended one hackathon a couple of days ago together with some developers from the team, and we were trying to build based on lots of data that our client has, some features, service dates and something like that. And we had 3 days to came up with some kind of proposal for the solution, and 2 days we were just digging into database and try to find what is real data that will affect the system. So it's not just enough to know this is the table, I'm going to use this table. Okay, this is the table, I'm going to create store procedure, mixed everything, pull that in another table. You need to have a knowledge about the data as well. So that's why I mentioned here, for example, I mean, I showed very, very simple database with just a couple of columns, but I had on purpose that deployment ID table, which is completely not relevant for predicting what tests should be executed. So you need to have knowledge about the system. You need to know what and how should affect the system, and then you go and try to dig into data to try to fix data quality issues and stuff like that. It's hard work, and it's often it's not just one person work. People knowing the product and people knowing what that data means should also be involved to say what is really important and what not. But because in the end, you can have, let's say, you can select 15 variables that will be the part of prediction process. But that is also very hard to maintain, because later on, you need to retrain your model when you get the new data to see how it will behave afterwards. And if you have a lot of variables, there is a huge possibility that you will have data quality issues, empty columns, or for example, if you need to work with numbers, some are nulls or not entered correctly and stuff like that. So in the end, you need to pick up a small number of variables, but which are really important. So having data sources and having knowledge, or at least working with persons who have knowledge about the data, is a must.
Yeah, I guess you can also start using more complex statistical analysis methods like principal component analysis, factor analysis to sort out which correlations you have to really reduce the amount of data to make the training more efficient. You mentioned a couple of tools here, and you said that they were kind of costly. I got a question here if there are other tools of course on the open source tools that can be used instead of Visual Studio plugins.
When it comes to building machine learning models, I know that there is a tool called RapidMiner. It is free. And it's very, very good. I had a chance to play around a little bit. The difference between this, what Visual Studio is giving us, Visual Studio has, let's say, already done the work for us. So we just need to select what is the best scenario for us and to have correct data and then to start training and evaluating. While, for example, RapidMiner tool for machine learning, for building machine learning models, you will need to create your model from scratch. So in that terms, you will need to have more knowledge about how the models are created, what some maybe functions to use and similar. But yes, RapidMiner, I found that it was very, very good for learning purposes. And when it comes to tools for software testing, I mentioned Apple Tools, which is expensive, very powerful, but very expensive. It's based on UI validation testing. For example, if something was a little bit changed on a UI, and especially it's useful for, let's say, e-commerce application, where when something is missing and something that you, for example, with Selenium hardly can evaluate, this tool will only immediately show the difference. I know that inside browser stack, there is one, it's also a new tool. I think it's called Percy. It has similar set of functionalities. It has, of course, limitations when it comes to browsers to be supported and operation system and stuff like that, but it's free and it's also very good for the start.
Thank you very much. Just going back to the setting up the models and selecting the kind of attributes do you need. So got a kind of a broad question here, but maybe you can provide some examples if there are some data attributes or some variables that you do consider for specific context or something like that.
For this case that we had, or I'm not sure.
Yeah, maybe also if you elaborate a little bit on other cases that you see that where it could be useful. So what kind of data would you like to base your models on?
Yes, well, for this case, I selected only these which were, let's say, maybe realistic tomorrow if we decide to try to implement this. But also one data that would be very, very beneficial for this model would be code difference between before and after deployment, because we know that sometimes when changes are done on some set of files on some code, that may be some basic changes, naming, for example, or I don't know, something very basic, but still we are not sure. And developers will say, we don't have a huge change here, just test some basic things. So having that, the difference, the code change before and after deployment would be, in my opinion, very good input parameter as well, so that we know if there is lots of lines of code changed, then okay, this we need to take this carefully. But I was investigating and trying to figure out, is it really possible to have that? Maybe it is, I'm not sure. So that's why I skipped, let's say, simulating that part of the data.
Okay, yes, thank you. I've received one question here regarding code scene, if that is better than automated testing used in a company, and if the demo was an example of it, because code scene has a much broader term. Yes, I can start answering that one, because code scene is kind of a very different tool, even though it's using AI in the bottom, but that has a, I wouldn't say, a completely different purpose. It could, of course, also help you, as in this demo, pinpointing which parts that you should maybe focus on, but not really helping you pinpointing which kind of test cases you should select. So that is yeah, different. So I don't know if you also have some reflection on that, Alisa.
Yes, I mean, it's a different, I mean, first of all, Code Scene is a very complex and complete project. This is just one short demo and overview what we can maybe try to have and to achieve. And yes, Code Scene actually, it of course has better prediction. It's a different, maybe it can be used to get some good data for test input, and then this could be maybe just extended way of using what Code Scene really has. Yeah, I think that's it.
Yeah, okay, yes. And with that, I would like to conclude this seminar, and thank you very much for this presentation and this demonstration of how it can be used. And you're, of course, feel free to reach out to us if you have some further questions, or if you would like to get some more details on how to do this and set things up. And thank you to all of you who have attended this seminar, and hope you all have a good day. Thank you very much.
Thank you very much for attending.
Thank you so much, Magnus and Lisa.
Thank you.
Thank you.
Bye.
Bye.